Question 9 of our exam will focus on Euclidean geometry. The very first question says that the circumcircle with center O is drawn around the cyclic quadrilateral gift GIF. A circumcircle is a type of a circle that will enclose or contain a polygon inside, and in this case we are saying that our polygon is GIFT, and we can see that we have the center there of that circle. Then the very first question says to us that prove a theorem which states that the opposite angles of a cyclic quadrilateral are supplementary. I believe that we know this theorem at this stage. So this theorem simply says that if I take this angle and I add to that angle, I should get 180 degrees, meaning they are supplementary. So these are the opposite angles. But there is a pair of opposite angles in a quadrilateral. So it means even if I take this angle and I add them, I should also get 180 degrees. They should be supplementary. And really, we have to prove that theorem in this question. The very first thing that we do in order for us to prove this theorem is that we are going to construct a line that moves from the circumference in one of the vertices. For instance, I can take the line that moves from I to O, and also construct the line from T to O, such that after I'm done doing this, I've created two angles in this quadrilateral. I'll have angle here and another angle here. I'll call this angle here angle O1, and I'll call this one angle O2. Now, when you answer this question, the very first thing that you do is that you tell the person who's going to mark your question paper that you have constructed those lines. It means you put this statement to say draw IO and TO. Those are the lines that we've drawn. And this means also that when you answer this question, you have to redraw this circle in your answer book so that you can show the examiner, the marker, I mean to say, this construction that you have done here. Now, let us look at how this construction assists us. If you look at the angles that we've created, they then relate to another theorem that we know, where we say that the chord IT subtends an angle here at the center, which is going to be angle O1. And the same chord IT subtends another angle at the circumference of the circle, which is G there. And if that happens, we know that the angle at the center is twice the angle at the circumference. So that means here, what I'm going to do is that I'm going to say angle O1 is twice angle G. Angle O1 is equals to twice angle G. And I'm going to give my reason here to say angle at center is equals to twice angle at circumference. And I do the same with angle O2, because we can see that, remember, that theorem has three diagrams that appear when we prove the theorem of angle at center is twice angle at circum. The other one that I see is that the same chord IT subtends an angle that is big here, O2, on the outside, on the other side. And if that happens, we also know that the same chord will subtend an angle on the other side of the circumference, which is angle F. And the same will be true. Those two angles will have a relationship such that the angle at center, meaning O2, will be equals to twice the angle at circum. And the reason really is still the same here, to say the angle at center is equals to twice the angle at circum. Now, after I'm done doing this, I can then combine my two angles to say if I add these two angles, angle O1 plus angle O2, I'm really going to add these two on this side. So this means I'm going to have 2 angle G plus 2 angle F. Now notice something very interesting here. If I take angle O1 and angle O2 and I add these two angles, they then become an angle around a point. In other words, they make a revolution. And we know somewhere in grade 7 or so, or something like that, that angles around a point, they add up to 360 degrees. So I'm going to argue here to say angle O1 plus angle O2 is equals to 360 degrees. Why? Because these are angles around a point. Very important to remember this theorem. Angles around a point are conjugate. They add up to 360 degrees. Now, when we look at these two equations and compare them, we can see that this side, the left-hand side, is exactly the same. That means I can argue to say this implies that if we have 2G plus 2 angle F, so if I have these two angles, I can say they are really equals to 360 degrees as well. Because remember, this is O1 plus O2, and O1 and O2 are equals to 360 degrees. This is very helpful because now when we simplify this, you would come to notice that I can take out the common factor so that I have angle G plus angle F. Remember, if you bring the 2 back here, you'll get the 2F, and if you bring the 2 there, you'll get the 2G and the 2F respectively there. Now this side we still have 360 degrees. Now when we divide both sides by a 2, we then have 180 that side. So it means here we are going to have angle G plus angle F to be equal to 180 degrees. Remember that if you divide 360 by a 2, it gives you 180. That's the half of that. But if you look at what we have done here, we're actually saying the sum of angle G and F, which is these angles here, G and F, they are equal to 180 degrees. They are supplementary. That means we have proved that this pair of angles are the same. Remember, we also have to prove these ones that they are the same. Now, when you do this one here, you are going to do the construction again, just like we did. We're going to say we draw a line FO and we draw a line GO. Do you notice that we are going to have two angles here? O2 this side and O1 this side. So we're going to have O2 and O1 this side. And you can see that we are going to follow exactly the same method that we have done here. Now, I'm not going to repeat that, and you should not repeat that in exam because this question is only for 5 marks. So to finish off this question, you will argue to say that similarly, joining or constructing the FO and the GO will result to angle T plus angle I being equal to 180 degrees, being supplementary. Because really, we will do the same mathematics that we did when we really constructed the first part here. We should follow the same method, and then therefore, these angles will also add up to 180 degrees when you follow that same method. And this will be out of 5 marks, and where the 5 marks will come from is going to be given for your construction and also applying your two theorems there. So the diagram that you're going to redraw in your exam and writing this statement will give you 1 mark. And the other mark will come from using the idea that angles around a point are conjugate, and then the other mark will really come from putting in the final mark. So this is for both these two. They should be able to give you 1 mark for that. The next set of questions that we are going to look at is 9.2, which says to us that cos or COS is a diameter of the circle centered at O. So if we look at this diagram here, we can see that we have COS, which is a diameter of this circle that is centered at O. Now, when we say this line is a diameter, it means we have half of a circle this side and another half of a circle this side. That means we have a semicircle here. We're dealing with a semicircle, half of a circle. The question further goes on to say cos is a cyclic quadrilateral and angle C1 is 30 degrees. So we are saying here that CARS is a cyclic quadrilateral, and of course you can see that that is a four-sided polygon which touches the circumference of the circle. In other words, we have a circumcircle. Now we are also told that the angle here is 30 degrees, which is angle C1. I think this is straightforward. The questions will guide us in terms of what can we do. Now, if we go to the question, it then says calculate with reasons. Very important. All the time when you do geometry questions, make sure that you specify the theorem that you have used as a reason. The size here, size of each of the following angles. So we're looking for the sizes of the angles here. Now we are doing question 9.2 and we are on 9.2.1. We are looking for the size of R here. And therefore, because this is a cyclic quadrilateral, the opposite interior angles, meaning this angle and this angle, because remember we're looking for R, the sum of those two angles must be supplementary. We know that theorem. So here, what I'm going to do is that I'm going to say angle R plus angle C1 must be equal to 180 degrees. They must be supplementary. How do I know this? Well, because I'm applying a theorem that says opposite angles of a cyclic quad are supplementary. From here, this question becomes very, very, very boring because we are going to substitute the 30 for C1 and we have 180 degrees, and this would indeed give us an answer of 150 because you say 180 minus 30. 2 marks for free here for finding the answer and also reasoning, putting in together your reason. So we know that here we actually have 150 degrees. The next question says that find TAS, which is angle TAS. Angle TAS, it is this angle here. We have said that this is a semicircle. We have this half part being the same as that half part. And there is a theorem that says that if the diameter subtends an angle at the circumference of the circle, that angle must be 90 degrees. So here it means I'm going to then answer this question quickly by saying now that we have angle TAS to be equal to 90 degrees. Why? Because we are having angle in a semicircle. $2 marks again for free. 1 for for writing your answer and giving the reason. Next question. So we know that here we have a 90. Now, the next question says we must find angle S1. When we look at S1, it's actually sitting here. And for me, I actually see cars here. I see a triangle CAS. And that means I can use the classical theorem that says the sum of angles in a triangle are supplementary. Now, that means we are going to say here 9.2.3, we have angle S1 plus angle A plus angle C is equals to 180 degrees. The reason for me to say this is 180 is because sum of angles in triangle CAS, right, the supplementary, the sum of angles in a triangle. Grade 12 learners, if at this stage you don't know this theorem or you can't see this, you suck. Going along to the next question, we are required to find angle C2. And when we look at angle C2 is here. Now again, we have said that we have a car here which is a cyclic quadrilateral. And this angle here, C2, is an angle outside of that cyclic quadrilateral, is an exterior angle in a cyclic quadrilateral. And we know a theorem that says the exterior angle is equals to the interior opposite angle. Interior opposite angle. Do you see that this exterior angle is exactly opposite? It is in front of R. So that is my answer. I'm going to say here we are doing 9.2.4 and angle C2 is equals to angle R, and this indeed will be equals to 150 degrees. Because already we know our R. We calculated the R here to be 150 degrees. Now, the reason for this would be that we have exterior angles of a cyclic quadrilateral. So here we're going to get the 2 marks, 1 mark for the answer and 1 mark for our reason. And just by the way, the previous question they give you 1 mark. That's why I said if you don't know this, you really suck, because this is like grade 7 again. You know, it's a theorem that you have done early in grade 7. They only give you 1 mark for that. Now we go to the next question, which is the last question really for this part of the question. 9.3. They say here that point T is connected to S such that TC and CS are equal. Let's look at what they're saying here. We construct here, or we extend T to S. And when after doing that, or when we do that, we do it so that these sides are equal. The length TC is the same as the length CS. Is that correct? Yes. TC is equal to CS. Now the question then says calculate angle T. Obviously you can see that after joining these lines, these 2 points, we are going to have a vertex here. It means we are going to form an angle. This edge here, the vertex will form an angle. And really we are required to then find this angle. Now when I look at this, for me it's an isosceles triangle, because really we have 2 sides in a triangle that are of the same length. That's the definition of an isosceles triangle. That means I'm going to use that theorem. But the first thing that I'm going to do is that I want to argue properly here, or to share with you how to argue in a top tier way. So we're going to have 9.3. I'm going to say here that TC is equal to CS. So I'm saying this length is the same as that length. Why? How do I know that? Well, is what I'm told in the question, so I'm given. Then because these 2 are the same, I then conclude to say angle T is the same as angle TSC. So I'm saying angle T here will be the same as angle TSC, as this angle here. So these two angles will be the same because they're the base angles of an isosceles. So this means here we're going to have TSC, angle TSC. The reason for this would be that angles that are opposite equal sides. Remember that theorem of an isosceles. It says that angles that are opposite equal sides, this is opposite that is opposite that, must be equal. Those angles must be equal. That's the theorem that we know of an isosceles. Now, these two arguments will assist me now to then look at this as a triangle. I mean, really, this is a triangle. It means then again, I'm going to use the sum of angles in a triangle. I'm going to then say angle T plus angle TSC plus angle C2, they must be equal to 180 degrees. I hope we don't suck. So here we're going to say the sum of angles in triangle TCS. But remember that we are saying that angle T and angle TSC, they are the same. So these two angles are the same. It means I can write them using the same symbol. Because I'm looking for T, I'm going to write them using T. I'm going to say both these angles are TT because they're the same really. But now in terms of our C2, we know that it is 150 degrees because we have done that at the top. And here we have 180. Now at this stage, I'm going to have 2T is equals to the 180 minus 150 should give me a 30 degrees. And we are now going to divide both sides by that 2. So that I have here angle T is equals to half of 30 must be 15 degrees. Now this question will carry really 4 marks. The first one would be applying this theorem there and the reasoning. Being able to see that the two angles are the same. You will get a mark for setting up that sum of angles in a triangle and also finding your final answer there.